Welcome. This video is on the scope triggered plot. So in order to enable the scope triggered plot, we need to pick the proper channel and trigger data. So we can pick any channel here, and then what we'll want to do is pick a trigger, and this is in this case is a speed signal. It's our tack signal. It's coming in as a square wave and then decoded as a speed. So in the setup panel on DS, I have it a speed channel 0, or is a speed named tack, and the tack ratio is 60. So it's going to convert hertz to cycles per minute, or RPM. Okay, so right now I have the tack set at 60 hertz, giving us 3600 RPM, cycles per minute. Alright, so let's make the plot. So we selected the channel, and then the trigger data, which we just talked about, is called tack, and we pick scope triggered. And let's go ahead and put it to let's make a square wave or sine wave, one of the two. And so this is what the triggered scope looks like. Now what we can do is we can change the x-axis scaling and see more data. So at this point it kind of looks like what the scope continuous plot does. You can take this up, I think you can take it up quite a bit, and you get to 1 second of data. So the difference, what this plot is, what makes it unique is that the starting point of this channel 1 is it's starting the plot when the tack crosses threshold. So when it's coming, so if you think of it as a rotating machinery, it would be 1 point. It's considered the crossing the threshold, and then engine would go around 360 degrees and then cross it again. So it's starting the data at that crossing every time, and what it's doing is it's accumulating the data out beyond that point. So we're basically starting at a fixed point based on the tack, and then the data is plotted in time out past that point. And so you can see if I change the frequency, it is doing what you would expect. You see the frequency change, amplitude change, signal. Now, the thing that can happen though with this plot is if the tack signal goes to 0, like I just took it down with the simulator, and then we take the frequency or change the signature, you notice nothing's happening. That's because it's waiting for the tack to cross the threshold and basically to come back around to start the next plot. But the tack is off. There's no tack signal. So if we we move the tack signal up, now we start to see the data again. And it's a bit slower because we're at 1 hertz tack signal, so we can take it up higher, and now we'll see the update a little bit faster. It's still accumulating 1 second of data, so it takes at least 1 second to get that filled up, but it's updating a little bit, triggering a little bit faster. Okay, so that is the scope triggered plot. And again, so like a regular, like kind of time-based plot that you can expand the x-axis out to many seconds. But the key is that it requires a tack, and it will basically start to trace or trigger on the tack signal. So that's scope triggered plot.